Well, no identity is going to be worth its weight unless we're able to prove it. And so I'm going to go through and we're going to talk about a proof of the quantity cosine of u minus v is equal to the cosine of u, cosine of v, sine of u, sine of v. And in this case, I'm actually replacing u and v with a and b. It still works the same way, but we need to isolate a few things. So let's go to this unit circle business. You recall on the unit circle, it was the kind of circle with a radius of 1. And in this radius 1 circle, of course, one thing that we can say is that every time we get a sine or a cosine, the values represent the actual x and the actual y coordinates at those points right here. So for angle B, for example, the x coordinate is cosine B and the y coordinate is sine B. Similarly for angle A, wherever angle A happens to be, and let's say in this drawing it comes out to be here, but this could be anywhere on our unit circle, that the x coordinate here is the cosine of A and the y coordinate here is the sine of A. Well, sort of an important point right here would be that, let's say that this is x2, y2, and this is x1 and y1, that we could find a distance between these 2 points now, right? And if you remember your distance formula, I have it here below, that the distance between any 2 points, and I'll call this distance 1, the distance between any 2 points is equal to the difference in the x coordinates squared plus the difference in the y coordinates squared, then we take the square root of that quantity. So what does that look like for us? Well, in our case, d1, this distance that we get up here, is equal to the square root of the difference in our x coordinates. So we're going to go x2 minus x1. So that's cosine of A minus the cosine of B squared. And for our y values, well, that's going to be the sine of A. Sine of A. Let's try that again here. Try to make everything look nice and neat here. Sine of B, sine of A, minus the sine of B. Getting ahead of myself. And we want to square that quantity, and then we're going to take the square root of everything in there. All right, and then for comparison, I actually took the difference between these angles A and B. So if we took angle A and subtracted angle B, that would be this angle that's formed in between them. And what I did was I moved it over here and put that angle A minus B in standard position. So that measured from the horizontal axis, the angle A minus B is shown here. And it is the same as the arc right here that would be shown between point B and point A would be the same. So what we can say then is that if we were to find the distance between this point right here at A minus B and the point at 1, 0, we would have an equal distance. I'm going to call this distance 2. So what do we have? Distance 2 in this case is also going to be likewise our difference in our x value. So let's call this x2 and let's call this y2. And let's call this x1 and y1 here at the coordinate 1, 0. So we're going to take cosine of the angle A minus B minus 1 and square that quantity. And we're going to say that if we add that to sine of the angle A minus B minus 0, square that quantity, we would have an equivalent distance between these two. All right, and of course we know that distance 1 must equal distance 2 in this setup, and so we're going to use that to our advantage right here, because if it's the case that distance 1 is equal to distance 2, then we're just setting these two distances equal to each other. Now, one of the first things that we can do is we can say, well, if the square root of the left-hand side is equal to the square root of the right-hand side, we can just get rid of the square roots altogether, because the quantities under the radicals must equal each other. And so we know that when we take the cosine of A minus the cosine of B, squared, and add that to the sine of A minus the sine of B squared, it should be equal to the difference cosine of the quantity A minus B minus 1 squared plus the square of the sine of A minus B, right? The 0 doesn't really even matter there, so it's sine squared of A minus B. Interesting, interesting. Okay, so let's see what we can figure out right here. This is a quantity squared, right? The square of a binomial. And we know how the square of a binomial goes, right? The square of a binomial was the kind of square that said anytime you took A minus B and squared it, you got A squared minus 2AB plus B squared. And in this case, keeping that in mind, we have two quantities just like that right here. So we can use this rule to expand our expressions for cosine and sine. So let's do that right now. So squaring cosine of A minus cosine of B is going to be cosine squared A minus 2 cosine A cosine B plus cosine squared B. And we're going to add that plus sine squared A minus 2 sine A sine B plus sine squared B from this expansion. And we've got one more expansion to do right here, and that's going to be cosine squared A minus B minus 2 cosine of A minus B plus 1, that's our expansion here, plus that extra sine squared A minus B. And it may have already struck some of you that there's something else that we can do now, because we are adding expressions that have sums of squares of sine and cosine. And we know that our identity tells us that anytime we take the square of the cosine of an angle plus the square of the sine of the angle, we get 1. So we're going to have a 1 right here. And let's see, what else do we have? Well, we have a cosine squared B and a sine squared B here, so that's another 1. So it looks like on our left-hand side, we're going to have 1. Let's see, let me write this out. We're going to have 1 plus 1 minus 2 cosine A cosine B minus 2 sine A sine B. And on the right-hand side, we might notice, well, we also have another sum of squares, because the square of the cosine of A minus B plus the square of the sine of A minus B, well, that's also equal to 1. And so we have 1 plus 1 minus 2 cosine of A minus B. And maybe you might already see it, right? Since this is equal to 2, and this is equal to 2, right? Then what could we say? Well, they're like terms that are added to both sides, so we can subtract 2 from both sides. And look at what we've got now. We've got negative 2 cosine of A cosine of B minus 2 times the sine of A times the sine of B. And lo and behold, that's equal to negative 2 times the cosine of the quantity A minus B. And so one last step remains. Divide everything by negative 2. What do you think is going to happen? Well, exactly what we think should happen. We're going to get the cosine of A times the cosine of B plus, right, negative 2 divided by negative 2, plus the sine of the angle A times the sine of the angle B, equaling to cosine of A minus the angle B. And that verifies the identity right here. There it is. Happy day.